This is one of the most controversial jets ever built. Not only is it the result of more than a decade of development and the successor to the legendary Flanker, but the West already claim it's just a copycat. It's a 5th generation state-of-the-art Russian stealth jet that apparently isn't stealth, and it's the future of the Russian Air Force, but they haven't managed to build more than 24. Controversial indeed. But it's possible that this aircraft is more than just a fluke. Is it just all Western propaganda? Or is it really a future dangerous underestimation of an adversary? Today, let's explore the history, the myths, and the truth behind the future of the Russian Air Force and their attempt at a stealth fighter, the felon from the East, the Su-57. I'm going to show you exactly why the Su-57 was a beast of its own. And let's start with the obvious comparison. The Su-57 does follow the wing design of the American 5th gen fighters, but this is where the similarities actually stop. Unlike the F-22 or F-35, the Su-57 follows the similar design of flankers, with engines located in gondolas and a tunnel between them to increase the maneuverability and lift performance. The vertical stabilizers of the Su-57 are canted, which is the main requirement of any stealth aircraft to minimize its radar return, but they're also used as a whole as a control surface, similar to the YF-23 design. Yes, that's right, the rejected YF-23 that the Americans didn't choose when they were looking at the F-22 program. And it's this jet that the Su-57 is actually much more inspired by than the Raptor. The nose section closely resembles not just the YF-23, but much more the NATF-23 concept, which was based off the YF-23 prototype, and we've done a whole video on the channel about this crazy Navy variant. The Su-57 kept the horizontal stabilizers and added LERX control surfaces, or leading edge route extensions, which can be used as sort of canards in flight, again with maneuverability top of mind. But this is where it gets a little weird. From the first prototype onwards, one notable design choice was the regular thrust vectoring nozzles and exposed titanium of its AL-41 engines. But I'll get back to why that's weird later. Another problem with the engine placement is the not fully hidden compressor blades inside the S ducts, even though the Su-47 had them hidden. Speculations about the actual stealth performance of the Su-57 started to flare up right away, with some people questioning that this design was even remotely comparable to the F-35 or the F-22 when it came to stealth. So let's squash that bug right now. The kind people at Aircraft 101 did an amazing work to settle the question of stealth once and for all. They created some highly detailed 3D models of some famous modern aircraft and then used mathematical model and radar scattering simulations to get the data of radar cross-sections over the wide range of frequencies. Meanwhile, a leaked document for the Su-57 stealth design patent actually stated that it has an RCS of 0.1 to 1 meter squared. This is much more than the F-35's 0.00015 or the F-22's 0.0001 meter squared, meaning that the Russian jet has the stealth characteristics of a brick wall. These numbers proved correct, however, there was a caveat. And trust me, we're about to get really technical, but it's the devil in the details. If we were to examine the results from the Aircraft 101, which does not include the effect of RAM materials, which can't be calculated with precision, the Su-57 has a median radar cross-section of 0.48 meters squared in a frontal 120 degrees. This coincides with the Russians' leaked report. However, an F-35's median RCS stands at 0.06 meters squared. So if we take a look at the diagram, it shows a very slight angle of which the F-35's radar cross-section drops to -35 or 0.0001 meters squared. But that's the minimal RCS, not the overall frontal RCS of the aircraft. So if you take into account the addition of RAM materials, and this paper on RAM material simulations can decrease the radar cross-section up to 90% when the whole object is covered in these materials. But here's the thing, the F-35 or any other jet is not covered in these materials. They only use it on the hatches or important sections where the radar waves might scatter back to the source. So a decrease in the median RCS can go anywhere between 20 to 90%, but not the 200 or 1000% that people have claimed. The bottom line is that there's no chance that the Su-57 can match the stealth characteristics of the F-35s or F-22s, but it's not as far for them as the media wants you to believe. Any modern radar would have trouble detecting and tracking a sub 1 meter squared target, so in the eyes of the Russians, it's stealthy enough. Although I do want to just draw back to those strangely exposed engines. On the side or back section of the Su-57, the radar cross-section is probably much higher than its American counterparts because of those engine issues. And then of course we have the famous exposed screws with the Su-57, but this is not a key factor because, well, as you could see, both the F-35 and F-22 also have exposed screws, and they are both still extremely stealthy aircraft. But it's the stealth that isn't the biggest issue with the Su-57, it's actually those engines. The Russians made the same mistake that put to trash so many projects throughout the Cold War. They started development of this jet without its new engines. Now that's not really a bad idea per se. I mean, the Rafale and the Su-27 and many other successful jets flew their first flight without engines designed for them, but that was a flaw that was quickly fixed. The Su-57 on the other hand still doesn't have its proper engines. The development of Dahlia 30 is a long and still not concluded story, and the serial production of the Su-57s fly with AL-41F1 engines similar to the ones used on the Su-35. And these are great engines, don't get me wrong. However, even though they are designed as Super Cruise capable engines for the MFI program, the ones inside the original Su-57 are not based on the original AL-41Fs because they were too large for the Phelon, and instead they're based on the older AL-31s, meaning the Su-57 might not be able to achieve Super Cruise in a full combat load, as the Su-35 can only achieve it in a light configuration. Yikes. Now the cool thing is about these AL-47s is that they have 3D thrust vectoring, giving the Su-57 amazing maneuverability, as well as the thrust to weight ratio over 1 with combat load, making it a beast for dogfighting. But this isn't the era of dogfighting, and this scenario is highly unlikely in modern combat. Sorry, Tom Cruise. The new Dahlia 30 or AL-51 engines are supposed to have the supercruise ability at Mach 1.5, serrated nozzles like the F135 engine on the F-35, and the ability to eliminate the exposed titanium area and maybe even more flat, more stealthy design as seen on the S-70 drone. But when exactly that's going to happen remains to be seen.